Hello viewers, we're now taking you through the story for A-level pure mathematics. And this video I'm going to go through the topic of circles. So this topic is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So before we start the topic, let's first go through the course outline. So pure math paper 1 or math paper 1 is divided into 5 parts. The first part is algebra, where 2 questions come in section A and 2 in section B, and these are the topics. Second part is trigonometry, where 1 comes in section A, 1 in section B, and these are the topics. Third part is geometry, where 1 comes in section A, 1 in section B, and these are the topics. Fourth part is vectors, where 1 comes in section A, 1 in section B, and these are the topics. And lastly, calculus, where 3 come in section A and 3 in section B, and these are the topics. So far the entire calculus has been covered on this platform, vectors has been covered, trigonometry has been covered, and algebra. So for algebra, this half a mark means that the video will be remade. So it's available on this platform, but the quality was not okay, so it will be remade after this entire topic of geometry has been completed. So in this video, we're going to go through the topic of circles. So you come as that a circle is a locus. So the good thing, we already covered the topic of loci in previously, so I believe this word locus is not new to you. So a circle is a locus of all points P, X, Y which lie at equal distances from a fixed point C, which with coordinates A, B, and that is point C will be called the center of the locus. So that locus will be in that form, where this is point C and this is the circle which shows the path taken by all those points which satisfy this condition for P, that the distance is always constant. And that distance will be denoted by R, which we call radius of the circle. And this fixed point will be called the center of the circle. So now what we want to do, we want to derive the equation of the circle, which we shall be using, but be reminded that it's available in your mathematical logbook. So if you go through the section of geometry in your mathematical logbooks and look at equation 32, it says that the general equation of a circle is this, where G, F, C are constants, and the center of the circle is given by this, and the radius of the circle is given by that. So basically this statement is what we want to derive, so that you can easily understand where it comes from when we start applying it in the questions. So for us, we have said that the center is AB and the radius is R. If you look at this, the center was told is negative G, negative F. So there's no need to worry, because we are going to derive, and at the end of the derivation you realize that we come up with this center and this radius. Though for now, this center now for us is AB and this radius is small r. So let's start the derivation. We shall say that suppose that the distance of point P from the fixed point C shown above is r. As we have already seen here, the distance is r. Therefore, we have to remember the knowledge of geometry 1, which gives you the distance between 2 points, because I have point C which is AB and point P which is XY. Therefore, the distance will be the difference in the y coordinates and square it plus the distance, so the difference in the y coordinates and square it, everything under root. Now here we have not put square root. Reason is because here it is also squared. But we know that CP is R. So what we are going to do, we shall come here and replace this with R. When you do that, we are going to come up with this, which is x minus a squared plus y minus b squared equal to r squared. So this is not yet the equation you want, but it's also very important because sometimes they will give you the center of the circle and the radius, and they tell you to find the equation of the circle. So if they do that, you begin from here and expand. So let's also do the same. Let us expand this form equation. So we know that r is the radius of the circle and point AB is its center. So next is to expand, because our aim is to get an equation which is this. I think this is expanded. So let's do the expansion. So when I expand this equation 1, this one will give me this, and this one will give me this, and this r squared remains. When I try to rearrange, because my aim is to, like I told you, the aim is to get this expression. So I have to rearrange that. I start with x squared plus y squared. So when I rearrange, I'll come up with this. But I still have a, b, and r. Yet in the equation I want it to have g, f, and c. So let's see how we can get that in the next slide. So to make the coefficients of x, y positive, we shall let a to be equal to negative g and b to be equal to negative f. The equation therefore becomes this. So I think we realize that here in this derivation, the coefficient of x and the coefficient of y are positive. Yet for us, in the previous expansion, the coefficient of x and y were negatives. Therefore, we have to do some letting, and we are going to let a to be equal to negative g and b to be equal to negative f, so that we can come up with this. So the reason why we are letting it to be negative g and negative f is to get an equation which is consistent to the one in your mathematical logbook. Therefore, you don't use any other letter. You make sure you use g and f. So when I do that, this and this gives you positive, this and this gives you positive, which is that, and this is that. Now for the case of simplicity, we are going to let c to be equal to this, because why are we using c? It is because, like I told you, we want to be consistent with the formula in your mathematical logbook. In your mathematical logbook, there's no other letter but c at this point. So even as this constant will be let to be equal to c, and when you do that, we shall come up with an equation which is that. And I think realize that this equation which you have got is exactly similar to this. So you have derived the general equation. Next is to get the center and the radius. So from c equal to g squared plus f squared minus r squared, when I make r the subject, r squared will be that. Therefore, the radius of the circle will be got by putting square root on both sides. And the center AB, remember A was there to be negative g, so where there is A, put the negative g, and B was there to be negative f, so where there is B, put negative f. So we have got this radius of the circle and the center, which is exactly in the form as it is in your mathematical logbook. So this statement is very vital. So that is why I tell you always to make sure that you buy a mathematical logbook, so that you can be eased of memorizing some of the formulae. So now that you have got derived the general equation, now let's see how the equation can be applied in the questions given. So question 1 came from UNEB 2006 paper 1 question 13a and says, form the equation of the circle which passes through the points A, which is that, B, which is that, and C, which is that. So Each time you see 3 points passing through a circle and they tell you to get the equation of the circle, always this will be the procedure. The first thing is to state the general equation of the circle from your mathematical logbook. The next is to remember that these points must satisfy the equation of the circle. Therefore, when I use point A, which is -1, 4, it implies that our x will be -1 and y will be +4. Therefore, I come and substitute for x and y and come up with an equation which has g, f, and c. I'm going to do that for all the points. When I use point B, which is 2, 5, come and substitute x is 2, y is 5. So we'll come up with equation 2, which has also those constants. Do the same for point C, and when I do that, substitute for x and y, I'll come up with that equation. Now from there, we shall be having 3 equations, equation 1, equation 2, equation 3, and 3 unknowns, g, f, and c. So when I have 3 equations and 3 unknowns, it implies that I can solve the equations simultaneously. Now I have to solve and be able to get the values of g, f, and c. Let me start by eliminating c by saying equation 2 minus equation 1. So when I do that, I'll come and get this. So this minus this is this, this minus this is that, this minus this is that, and this minus this has been eliminated. I can reduce by 2 by dividing third by 2 to come up with this and call it equation 4. Then equation 2 minus equation 3, when I subtract the 2, I'll come up with this. So this minus this is this minus 0 is this, and this minus this is that, and this one is eliminated. I can also reduce by dividing third by 4. So I have equation 4 and equation 5 having only 2 unknowns, therefore I also solve them simultaneously. I'll come and say that equation 5 minus 2 times equation 4, it will give me that. So this and this gives you this, this and this gives you that, and this is eliminated. Therefore my aim is to make g the subject, and g will be -1. So now that I've got the value of g, I can go back to equation 4 and substitute for g and be able to come up with the value of f. So f will be -3. Now I have got g and f, I'm left with c. Now for c, I'll go back to equation 3. Any equation will work. We can either go to equation 1, 2, or 3 and substitute for g and f, then you'll be able to come up with the value of c as 5. So now I have got the value of g, the value of c, and the value of f. Therefore, I will go back and say that the required equation of the circle is this, by replacing where there is g, replace it with -1, which I've got, where there is f, replace with the -3, which I've got, and where there is c, replace with 5. When I simplify, I'll come up with the required equation of the circle. So basically, that is how they go about such questions. But for the case of mastering the concept, let's go through a number of questions. So question 2 came from UNEB 2005 paper 1 question 12A and says find the equation of the circle which passes through the points this, this, and that. So still we shall quote the general equation of the circle, then I'll use point by point. When I start with this one, x is 5, y is 7, therefore substitute for x and y and come up with equation 1. Next is to use this point, x is 1, y is 3, therefore substitute for x and y, then get equation 2. Then lastly this point, x is 2, y is 2, therefore substitute for x and y, then come up with equation 3. So we have 3 equations and 3 unknowns. Next is to solve simultaneously. Equation 1 minus equation 2 will give me this. When I reduce, I'll come up with that, and that will be equation 4. Then equation 2 minus equation 3 will give me that. When I reduce, that will give me equation 5. Now equation 5 and equation 4 have only two unknowns, therefore I will solve the two equations simultaneously. Therefore equation 5 minus 5 times equation 4 will give me that. So next is to make G the subject, and G will be negative 3.5. Now that I've got G, I can go to equation 4 and substitute for G and be able to get the value of F as negative 0.45. Then now from equation 2, I can substitute for G and F to come up with the value of C as 24. So when I get G, F and C, I'll just go back to the general equation of the circle and substitute for G, F and C. Then simplify to come up with the required equation of the circle. So basically that is what they wanted. So question 3 says, find the equation of the circle passing through the points 0, 1, 4, 3 and 1, negative 1. So I believe by now we have mastered the concept. So what we are going to do is to just go through this solution quickly. So the general equation of the circle is that. So using this point, I'll substitute for x and y, then get equation 1. Then using this other point, I'll substitute for x and y, and then come up with equation 2. Then using this third point, substitute for equation 1 to give you that, and then get equation 3. So equation 3 unknowns, solve them simultaneously. Equation 2 minus 3 times equation 1 will give me that as equation 4. Then equation 3 plus equation 1 will give me that, and that will be equation 5. Now equation 5 and equation 4, there are two equations and two unknowns, therefore I also have to solve them simultaneously. So equation 4 plus equation 5 will give me that, therefore the value of G will be negative 2.5. Then from equation 5, I can substitute for G and be able to come up with the value of C as that. Then from equation 1, I come and substitute and be able to get the value of F as that. So now I have the values of G, F and G, C and F. Therefore, come and substitute in the general equation of the circle to give you that, and then simplify to get the required equation of the circle. So basically that is what they wanted. So now we shall go to question 4, which came from UNEB 1997, paper 1, question 5, and says ABCD is a square inscribed in a circle this. Find the length of diagonals and the area of the square. So this one requires something like a sketch. So we shall first sketch the circle and the square. So for a square, this angle must be 45 degrees because this length and this length are the same. Then this is the radius and this is also the radius. So this diagonal passes through the center of the circle. So you come and quote the center, the equation of the circle. Then from here, G is half of this coefficient of x, which is that, and F is half of this coefficient of y, which is that, and C is this constant, but it has to go this side. That's why there is a negative there. That implies that the radius can be got from this formula. So substitute for G, F, and C to come up with 6.5 units. Therefore, the length of the circle is twice the radius, which will be 13 units. The length of the side is got by, because I have this one and this angle, I can easily get this length AB. So AB will be 13 cos 45, which gives you 6.5 root 2 units. Then they also wanted the area of the square. Area of the square is the length of one side squared. So you come up with 84.5 square units. And basically that is what they wanted. So now we shall go to the next part, which is intersection of a circle and a line. So you consider the equation of a line being in this form and the equation of the circle in that form. So these constants are not the same. One is C1, another one is C2. Therefore, substitute for y into the equation of this circle, so I'll get this expression of y and substitute it where there is y in the circle. When I do that, this is what I'm going to come up with. Then when I expand, this gives me that, and this gives me that. Now next is to rearrange and collect like terms: x squared alone, x alone, and constants alone. Therefore, by comparison with the general quadratic equation, which is ax squared plus bx plus c, it implies that a is this quotient of x squared and b is the whole of this and c is the whole of this constant. So with that, there are some things we need to note. Our interest is this one, which we call the discriminant. I think you remember that under the topic of quadratic equations. So if this discriminant is greater than 0, it implies that the line, this line, cuts the circle at two distinct points. What does that mean? It means that the line is the chord of the given circle. So when a line cuts the circle at two distinct points, that line becomes a chord. Then another thing we need to note is that if the discriminant is equal to 0, then the line just touches the circle at only one point. What does that mean? It means that the line is a tangent to the circle. Then if the discriminant is less than 0, or if it is negative, it implies the line neither cuts nor touches the circle. So the line is not a chord and also it's not a tangent. Now those are the three conditions which may arise. So with that, let's go through these questions. Question 1 says, show that part of the line this is a chord of the circle this, and hence find the length of this chord. So given this line, we shall rearrange and make y the subject to come up with equation 1. Then in this equation 2, which is the equation of the circle, what we are going to do, we shall substitute equation 1 into equation 2 to come up with that. So where there is y, we put there that. Then when I expand this, I'll come up with this. And when I take these two inside, I'll come up with this. Then cross multiply out by the LCM, I'll come up with that. So when I'll collect like terms and simplify, I'll come up with that, which is a quadratic, and I can reduce to come up with this. Therefore, remember that for the line to be a chord to the given circle, the discriminant must be greater than 0. So in this case, a is 1, b is -5, and c is -14. Therefore, come and substitute for b, and for a, and for c. Simplify, I'll come up with that. Therefore, this is true because eta 1 is greater than 0. Now, because it is true, it implies that the given line is a chord. Then for the hence part, they told us to find the length of this chord. So the length of the chord, we shall first get the points of intersection. So when I use this formula to solve this quadratic, I will remember that the whole of this discriminant inside was eta 1. So I'll come and put the eta 1. Then b was -5, therefore negative b will be +5, and a was 1, which is there. So when I use the calculator, x will be either equal to -2 or +7. Now from equation 1, I have to get the corresponding values of y. When x is -1, y will be 1, and when x is 7, y will be 4. Therefore, the points of intersection are a and b. Now the length of the chord is distance A from A to B, which will be given by the difference in the x coordinates squared plus difference in the y coordinates squared, everything under square root. So now as the calculator, I'll come up with this as the required length. Then question 2 says, prove that the line this is a tangent to the circle that. So still we shall go through the same procedure. That line will be equation 1 and this equation 2, so I'll substitute equation 1 into equation 2 to come up with that. Then expand to come up with that, and collect like terms, reduce to come up with that. So that is a quadratic. Next, I'll remember that for the line to be a tangent, the discriminant must be equal to 0. So come and substitute for A. So A is positive 1, B is negative 2, and C is positive 1. So come and substitute, simplify, you come up with 0 equal to 0, which is true. Therefore, the given line is tangent to the given circle. Then now we shall go to question 3, which says that prove that the line this neither cuts nor touches the circle this. So the same procedure, that is equation 1, equation 2, then substitute equation 1 into equation 2 to come up with that. Then expand, collect like terms, reduce to come up with that quadratic. Therefore, remember that for the line to neither cut nor touch the circle, the discriminant must be less than 0. So I'll come and substitute for A, B, and C to come up with that, which is true. Therefore, the given line is neither tangent nor a chord to the circle. Then question 4 says, find the equation of the circle which touches the line this and has a center that. So I'll first make a simple sketch. So touches means it's a tangent. Therefore, the distance of this point from a line will be the radius. I think remember that under coordinate geometry 1, we learned how to get the distance of a point from a line. Therefore, the radius will be the distance of this point from this line, which is given by this formula. So how to get it? This coordinate, x coordinate is 4 and y coordinate is negative 7. So when I substitute for that, I'll come up with this, and when I substitute for y, I'll come up with this. Then bring this one this side, that's why there is negative 9. Then for the denominator, look at the coefficient of x, square it, coefficient of y, square it, everything under square root. And don't forget to put the magnitude sign. Therefore, the radius is 5 units of that circle. Now that I have the radius and the center, I remember the other first equation we derived, which says x minus s squared plus y minus b squared equal to r squared. That's what I'll use. Then after that, but that is not the end of the equation. You have to expand and simplify. So when I expand, I'll come up with that. Simplify, I'll come up with that as the required equation of the circle. So now we shall go to question 5, which came from UNEB 2017 paper 1 question 10, and says a circle whose center is in the first quadrant touches the x and y axis and the line this. Find part A, the equation of the circle, and part B, the point at which the circle touches the x-axis. So there we shall come and say that this, from this equation of the line, when x is 0, y will be negative 8. And when y is 0, x will be this. So we are getting those intercepts because we have to make a sketch and draw, and we need to draw that line. So when I have the x-axis and y-axis for the circle, they have already told us that it touches the x and y axis, so that one is easier to draw. But for the line, you have to get the intercepts so that you can easily draw a correct line. So this is the equation of the line, this passing through the intercepts. Then for the circle, it touches the x-axis, it touches the y-axis, and it also touches this line. So at all those points, the distance from the center to that point of where it touches will be the radius of the circle. So this is r, this is r, and this is also r. Now because this is R and this is R and this is the origin, it implies that the center of the circle will be R. So that's sketch. Now let's go and get the required equation of the circle. So the radius is the distance of a point from the line. So the point R from the given line of the tangent is given by this formula. I think you remember that. So we shall simplify to come up with that. So this magnitude shows that what is negative becomes positive. Then cross multiply, collect like terms and get the value of R. So the radius is 12 units. So now that I've got R, it implies that the required equation of the circle shall start from here, because now I know the center and the radius. Therefore I'll start from here, but that will not be the end. I have to expand and simplify. So when I expand and simplify, I'll come up with the required equation of the circle as that. Then for part B, they ask for the point at which the circle touches the x-axis. So at the point at which the circle touches the x-axis, y will be equal to 0. Therefore, from this equation, you'll realize that x is also equal to 12. Therefore, the required point is 12, 0. Then question 6 came from UNEB 2006 paper 1 question 13b and says the line this is a tangent to the circle this. Find the coordinates of the points of contact of the tangent for each value of C. So from this line, make y the subject, you'll come up with that. Then from this circle, substitute for y to come up with that. Then expand this to come up with this, and also open brackets for this to come up with that. Then next is to collect like terms, x squared alone, x alone, and constants alone. So I have that. Therefore, for tangency, for this line to be a tangent for this circle, the discriminant must be equal to 0. So come and substitute b is this, c is this, and a is that. So substitute for b and c. Then simplify. So this 2 squared and this 2 and this 4 can cancel, so remain with 2 minus 6 squared, and here it remains with the 2 and this one. Then expand further. This one expanded gives you this, and opening brackets for this, you come up with this. Collect like terms, you'll be able to come up with that. They'll factorize and get the two values of c. C will be 0 or c will be equal to 4. Now they told us for each value of c, get the point coordinates of the points of contact of the tangent. Therefore, from this, when c is equal to 0, shall be able to come up with that, and therefore the value of x will be -1, implying that from this step, remember we saw that y is equal to c minus x. Therefore, substitute for c and for x to come up with the value of y as 1. Then when c is equal to 4, substitute c in this equation for c to come up with a quadratic. Reduce, and then you can either factorize to come up with the value of x as +1. Therefore, the value of y will be +3. So that implies that the points of contact are -1, 1, and 1, 3, which are these ones. So now shall go to question 7. Question 7 came from UNEB 2005 paper 1 question 12b and says Roman 1, if x is equal to 0, y is equal to 0, are tangents to the circle this. Show that c is equal to g squared and is equal to f squared. So I think let's start with that. So that is the given equation of the circle. So considering tangent to y equal to 0, it implies that where there is y, put 0 to come up with that. Then from there we shall see that for tangent C, discriminant must be equal to 0. So substitute for b is this, then for a is 1 and c is c. Therefore you will come up with that. Therefore c is equal to g squared. Call it equation 1. So that was for tangent y equal to 0. What about for tangent x equal to 0? So for tangent x equal to 0, still substitute for x equal to 0 to come up with that. Therefore for tangent c, discriminant is equal to 0, so substitute for b, a and c. You will simplify and come up with this. Therefore combining equation 1 and 2, you will come up with this, and that's what was required. So now shall go to Roman 2. Roman 2 says, given that the line this is also a tangent to the circle in B Roman 1, so in Roman 1, above, determine the equation of the circle lying in the first quadrant. So that was the equation of the circle given, but we already know that this is true. Therefore it implies that I'll come here and say that where there is f, you put there g, and where there is c, you put there g squared to come up with that. Also, we know that for this line y is equal to this. So what I'm going to do, I'll substitute for y. Then multiply that by the LCM, and then you can expand. So when I expand this, I'll come up with this. Expand this, I'll come up with this. So simplifying, I'll come up with that. Collecting like terms, x squared alone, x alone, and constants alone. So that will come up with that. Therefore, for tangent C, discriminant is equal to 0. So B is this, A is this, and C is the whole of that. Therefore, this 4 can cancel on both sides to remain with that. Then expand this to come up with that. Open brackets for this to come up with that. Then for the whole of it, you will come up with that. Then when I collect like terms, I'll come up with that, which is a quadratic, so I'll have to solve the quadratic. I can use factorization or bulldozer. So when I use bulldozer, I'll come up with values of g as g is equal to -1 or g is equal to 3/2. Therefore the center of the circle G is -g, -f. I think you remember that from the general equation of the circle. So that means this becomes +1 and f will be also +1. Then here, because we know that g is equal to f, that is why also f is that. Then here, when negative of this is this, and also f will be that, because we saw that f is equal to g. But remember, they told us that the circle must be in the first quadrant. Therefore the correct center will be this, because this one is in the negative is in the third quadrant. Therefore that means implies that g cannot be equal to this. Therefore g, the correct value of g is that. Hence the required equation of the circle will be, remember this is what we had, so I'll substitute for g to come up with that. Then question 8 came from UNEB 1996, paper 1, question 11, and says, part A, find the equation of the circle circumscribing the triangle whose vertices are this. Then find also the center and radius. I think let's start with that one. So the general equation of the circle is given by that. Using point this, I'll come up with substitute for x and y, then come up with equation 1. I think remember that. Use this point also, substitute for x and y, then come up with equation 2. Then use this one also, substitute for x and y, and then come up with equation 3. So we have 3 equations and 3 unknowns. Therefore, solving them simultaneously, I'll come and say that equation 3 minus equation 1, I'll come up with that. Reduce to come up with equation 4. Then equation 3 minus equation 2, come up with that. That will be equation 5. Therefore, now 4 and 5 have 2 unknowns. Therefore, I'll come and say equation 5 times 8 times plus 8 times equation 4 will give me this. Therefore, making G the subject, G will be that. From equation 4, I'll substitute for G and get the value of F. Then from equation 1, I'll substitute for G and F to come up with the value of C. So now that I've got G, F and C, I can easily get the equation of the circle. So the required equation of the circle is that. Substitute for G, F and C, then reduce, multiply by the LCM to come up with that. The center, they also wanted the center. Center is negative G, negative F, which is that. And the radius is given by this formula. Substitute. Then use a calculator to come up with that. So now shall go to part B. Now part B says that the tangent, if the tangent to the circle at this meets the x-axis at P, which is h0, and the y-axis at Q, which is 0k, find the values of h and k. So here we shall need a sketch. So let us draw the x-axis, y-axis, label them, then draw the circle, and that point, the points where the circle passes. Then our interest is the tangent through point A, which is that. So it touches the x-axis at this point and y-axis at that point. So basically that's what was given. Therefore, we know that the gradient of the tangent will be got by differentiating the equation of the circle. So when I differentiate, I'll come up with that. This gives you this, this gives you that, this gives you this, and this gives you that. Then this is 0. And also this is 0. So simplify, I'll come up with that. Make dy dx the subject, gives you the gradient function. Therefore at this point, x is this, y is this. Therefore when I substitute for x and y, I'll be able to get the gradient of the tangent, which is that. Therefore the equation of the tangent will be given by changing y by changing x equal to this gradient. Cross multiply, open brackets, collect like terms. So next is, now here, remember they told you to get the values of h and k. Therefore the tangent cuts the x-axis at y equal to 0. So now that I've got the equation of the tangent, I can be able to get that value. So when y is equal to 0, I'll come up with this, implying that x is that, therefore h is that. Also the tangent cuts the y-axis at x equal to 0. So when x is equal to 0, I'll come up with this, therefore y is this, implying that k is equal to that. And basically that is what they wanted. So now we shall go to question 9, which came from UNEB 1993, paper 1, question 12, and says the equation of a circle center O is given by this, where A, B, C are constants. Given that 4a is equal to 3b, 3a is equal to 2c, and c is equal to 9, part A, Roman 1, determine the coordinates of the center of the circle. Roman 2, determine the radius of the circle. I think let's start with part A. So first of all, we are given that c is equal to 9. Therefore, from this, I'll come up with a as 6. Then from this, I'll come up with b as 8. Therefore, the equation of the circle, remember it had ABC. So I'll come and substitute for a, b, and c to come up with that as the equation of the circle. Now, by comparison with the general equation, this g is the half of the quotient of x, f is half the quotient of y, and c is this constant. Therefore, the center is negative g, negative f, so negative of this and negative of that. Then for Roman 2, radius will be given by this formula, so substitute and come up with this as the radius. So now shall go to part B, Roman 1. So part B says that a tangent is drawn from point Q, which is 3, 2, to this circle. Find, Roman 1, the coordinates of P, the point where the tangent meets the circle. Then 2, the area of triangle QPO. So we shall first make a sketch. This is the center, and this point Q, and this is the tangent. It meets at point P, meaning that this is 90 and this radius was 4 units. So by Pythagoras theorem, OP is equal to PQ plus, OP squared plus PQ squared is equal to OQ. So this squared plus this squared is equal to this hypotenuse squared. Therefore, come and substitute. OP was 4 units. Then this is the difference between these two coordinates, is got by this formula, and OQ from O to Q is the distance between those two coordinates, is given by this formula. Therefore, expand, you'll come up with that. Simplify, you'll come up with that. Therefore, when I rearrange, you'll come up with equation 1 having B and A. So point P, which is AB, also satisfies the equation of the circle. Therefore, from that equation of the circle, come and substitute for A and B. You come up with equation 2. Therefore, solving the two equations simultaneously, I'll say equation 2 minus equation 1 to come up with that. When I reduce, I'll come up with that. Therefore, B is equal to that. So remove this one. Now, substituting equation 3 into equation 2, you'll come up with this. Now, this is solving simultaneous equations by substitution. So expand, I'll come up with that. Reduce, will come up with that. Therefore, using the bulldozer method, value of A can be this or that to 2 decimal places. Now from equation 3, I'll say that when A is that, B will be that, and when A is that, B will be that. Therefore, the required coordinates of P are this and that. Therefore, Roman 2, using this point, P2 is that. Remember, the good thing is that the area, the triangle is right angled, so I can just get base and height, then I get the area. So P2 is that, implying that area is the half times OP times P2, which is that. So I can either use this point, or I can also use the second point, and is okay. So if I use the second point, P2 will be given by that. Therefore, the area will be that. So any of the two options is okay. Then question 10 says, find the length of the tangent from a point 80 to a circle that. So by comparison with the general equation, it implies that G is that half of the coefficient of X, and F is half coefficient of Y, and C is this constant. Therefore, the center of the circle will be negative G negative F, which is 2, 4. And the radius is given by this formula. Substitute and come up with 5 units. So with that, I can come up with a sketch. So this is the tangent, and it comes from point A. This is the center, and this is the radius. They want the length of the tangent, means they want distance AB. Therefore, first of all, OA is this, and OB we already know is 5. Therefore, AB will be equal to this. So substitute and use the calculator to come up with that as the required answer. So we shall now go to intersecting circles. So here we shall consider two circles with the centers A and B, and radius RF and RB respectively. So the circle with center A has radius RA, circle with center B has radius RB, and circle A has a bigger radius than circle B. In other words, circle A is bigger than circle B. There are a number of possible situations that follow. So there are a number of cases. So case 1 is when the circles touch externally. So when they say that the circles touch externally, it means that they are in this form. They only touch at one point. And in that case, the condition for circles to touch externally is that AB, or the distance between of separation of their centers, is equal to the sum of their radii. Then case 2 is when the circles intersect at two distinct points. It implies that the separation of their circles is smaller than the sum of their radii, and to be in this case, in this form. Then case 3 is when the circles touch internally. So internally it means that they are in this form, and then the condition is that the separation of their centers is equal to the difference between their radii. Then case 4 is what we call concentric circles. So these are circles which have the same center. So these two circles are concentric. And lastly, we shall go is what we call orthogonal circles. So these are circles whose tangents at the points of intersection of the circles are at right angles. So since the radius through a point of contact is perpendicular to the tangent, it follows that the tangent is the tangent to one circle is the radius of the other. Therefore, just as you see them here, this is the tangent to circle A and this is the tangent to circle B. So the tangent to circle B is the radius of circle A, and tangent to circle A is the radius of circle B. And this angle must be 90. Then A and B are the centers. So in that case, it implies that we use Pythagoras theory, where AB is the hypotenuse. It will be equal to this squared plus this squared. So that now let's go through some of the questions. Question 1 says, show that the circles this and this are orthogonal. So if they are orthogonal, they will be in this form, circle A and circle B with center B. Therefore, this angle must be 90. So what we are going to do, we have to get the radius of both circles. So for circle A, G is that, F is that, and C is that. Therefore the center of A is that, and radius of A is given by that. That was circle A. What about circle B? For circle B, we have that. Therefore the center is given by that. What about the radius? The radius will be given by that formula, which gives you this. So now I have the radius and I also have the center. Therefore the separation of the centers is given by this. I think remember that distance between 2 points. All that I'll come and remember the condition for orthogonal circles is that AB squared is equal to R squared plus B squared, RB squared. Therefore come and substitute for this, for this, for that, and see if it is true. So it is true that because 50 is equal to 50, therefore the circles are orthogonal. So now we shall go to question 2, which says that find the equation of the circle which cuts orthogonally this circle and passes through point 30 and touches the x-axis. So we shall label the axis, then we shall remember it passes through this point and touches the x-axis, meaning that it touches the x-axis at that very point. So the radius of the circle is RA, and because from your T is 3, it implies that the center will be 3RA. Then this circle will now be here, and it also has a radius RB, so that this angle is equal to 90 because of that word orthogonally. Now for circle B, G is that, B is that, and F is that, therefore C is that. That means that the center is that, and therefore the radius is also that. So this circle we have the radius and the center. So for orthogonal circles, AB squared is equal to RA squared plus RB squared. I think you remember that. So I'm going to substitute AB squared is that distance between 2 points. Then RA squared, you don't know it, and this one is that. So open brackets will come up with that. Reduce and calculate terms to come up with that. Therefore RA is equal to 5/3. The center of circle A will be given by that. The required equation of circle A is therefore given by that format because we have the center and the radius. But that is not the end, we have to expand. So when I expand, I'll come up with that. Simplify, I'll come up with that. Therefore multiply through by LCM to come up with that as the required equation of the circle. Then question 3 says a circle with center P and radius R touches externally both circles this and that. Prove that the x coordinates of P is this. So they have told us that they touch externally. So for this circle, center is this and radius is that. And for this circle, G is that, F is that, and C is that. Therefore the center will be this and the radius will be that. So I'll come and make a sketch. That will be circle this one, which has center 0 0 and radius 2. The another circle, it has center this and radius 1. And the circle with center P, which touches both circles externally. So if this one, remember they told us it has radius r, so this distance is r, and this one is also r. Then for this circle, the radius was 2 units, so that's why you see here 2 and also here 2. Then this one, the radius was 1 unit, that's why you see a 1 and 1. So now we shall see that OP squared is equal to this. Remember, distance between 2 points is given by this formula, by squared, that's why there is no square root. And so that distance is also 2 plus r. Therefore, that will be equation 1. Then also QP is given by this formula, by this. And that distance is also equal to 1 plus r from the diagram. So that will be equation 2. Now equation 1 minus equation 2 will give us this. So 1 minus equation 2, this cancels, so this minus this gives you this, and this minus this gives you that. Then when I expand, this will give me that. Then here I will use difference of two squares, sum and subtraction. Then in the end I'll come up with this. So when I collect like terms and make x the subject, x will be equal to this, and that's what they wanted. Then question 4 says, show that the circles this and this intersect at 2 distinct points and find the equation of the common chord. So we shall need a sketch that is circle 1, and this will be circle 2. And now this will be the common chord. So shall first write those two circles, this and that. So at the point of this, so when I solve them simultaneously, I'll say equation 2 minus equation 1 to come up with that. When I make y the subject, I'll come up with equation 3. Now substituting equation 3 into equation 2, I'll come up with this. Expand to come up with this. Then multiply followed by the LCM to come up with that. Collect like terms to come up with that. Reduce to come up with that. So for intersection of at 2 distinct points, it implies that discriminant is greater than 0. Therefore, A is 1, B is 1, and C is negative 2. So come and substitute for A, B, and C. Then 9 is greater than 2 is greater than 0, which is true. Because it is true, it implies that the line casts the circle at 2 distinct points. They also wanted the points where it casts, therefore, when I solve this one by bulldozer method, I'll come up with this method, but I already know that the whole of this is equal to 9. Therefore, I'll come and put 9 there, and then be able to come up with the values of x as x equal negative 2 and x equal to positive 1. Now from equation 3, when x is negative 2, y will be 2, and when x is positive 1, y will be 3. Therefore, the chord or the common chord passes through the 2 points, this and this. And this equation is given by that. So cross multiply, open brackets, and this will be the equation of the common chord. Then question 5 came from UNEB 1992, paper 1, question 7. It says a circle A passes through point this and has center this. Another circle B has radius this and has its center this. Roman 1, determine the equations of the circles A and B in terms of t. Then Roman 2, if t is equal to 1, find the points of intersection of the two circles. And Roman 3, show that the common area of intersection of the circles A and B is that. So let's start with the Roman 1. So for circle A, radius is given by that, and center will be that. Therefore, the required equation of circle A will be given by that. Remember, this is the general equation, so I'll come and substitute for radius and for the center to come up with that. So when I expand, I'll come up with that, rearrange to come up with that. So that is equation of circle A. What about for circle B? For circle B, radius is that, and center will be that. Therefore, the required equation of the circle will be given by that. So come and substitute for center and radius. And then expand. Then next is to rearrange and collect like terms to come up with that. So that was Roman 1. For Roman 2, Roman 2 says if t is equal to 1, find the points of intersection of the two circles. So from circle A, when t is equal to 1, come and substitute for t to come up with that as equation 1. Then for circle B, also substitute for t to come up with that. So I have to solve the two equations simultaneously to come up with the required point. Therefore, equation 2, 1 minus equation 2 gives you this. Therefore, make x the subject, x will be equal to 2. Now from equation 1, I can come and substitute for x to come up with the value of y. Y is a quadratic, so I'll use bulldozer method to come up with the two values of y. Therefore, the required coordinates of the point of intersection are this and that. So that was Roman 2. Roman 3 said, show that the common area of intersection of circles A and B is given by this. So the good thing, we already know the center of those circles and their radius. So center of circle A is that, and center of circle B is that. So you have 2 points, C1 is this and C2 is that, then this point D is this and this point F is that. Now the area they want is this area which is shaded. So to get it, we shall need these two lines showing the radius. Both circles have the same radius, which is 2, 2. So this angle will be 2 theta. Now let's see how the area can be got. First, we shall get the distance from C1 to C2, which is 3 minus 1, which is 2, because if you look at this, the y coordinates are the same. Then what about C1E? From me up to here will be half of C1 C2, which is 1 unit. Then DF from me up to here, if you look at these two, the x coordinates are the same, therefore the distance will be the difference of these two y coordinates, which gives you 2 root 3. That means that DE is half of that, which will be root 3. So after that, I can now get the area of triangle DCF1, DC1F, the whole area of the triangle. It should be given by a half base height, which is root 3. Also tan theta, so remember the whole of this is 2 theta, therefore from here to here is just theta. tan theta is equal to opposite over adjacent, so DE over C1 E1, which gives you 60 degrees as the angle theta. Then the area of the minor sector DFC1, so the area of the minor sector is this. So remember the area of triangle, it was only the whole of this, only this one. Then the area of the minor sector is from here to here, then also to the whole of this, and also here. That is the minor sector. So the whole of that area will be given by that angle 2 theta over 360 multiplied by the area of a circle. And 2 theta will be 2 times 60 degrees over 360 times area of the whole circle with the radius 2. So we'll come up with 4 pi over 3. The area of the minor segment DF. Now minor segment will be the whole, this one alone. Remember, we got the whole of this, which is area of the minor sector, then the area of the triangle was this, implying that the area of the minor segment will be the difference in the two areas. That is why you subtract the 2. Then the common area of intersection will be twice that area, which is this. But remember, we have to express in the form which was given in the question. So this will be 8 here, and this is, now this 4 and this 4 cancels, remain with pi over 3, and this one is root 3 over 4, and that's what they wanted. So now we shall go to circles involving loci. So the good thing, the topic of loci was already covered previously, so I believe this part will not be confusing. So there's nothing to write because we already know what a loci is and also know what circles are. So this topic is just a combination of the two topics. So question 1 came from UNEB 2004 paper 1 question 5 and says A is the point this and B is the point this. P is the variable point which moves in such a way that AP squared plus BP squared is equal to 34. Show that the locus describes a circle and hence find the radius and center of the and radius of the circle. So let P be xy. Then this is the condition which was given in the question. Therefore, AP is the distance between this point and this point. Distance between 2 points, I think you already know it, so it will be that. Then PB between this and this point, it will be given by that. They told us it's equal to 34, so we put 34 there. Now the square and the square root will cancel to remain with this on this side and this on this side equal to 34. The next is to expand. I have to expand and collect like terms and rearrange. So when I expand, I'll come up with that. Then collect like terms and rearrange to come up with that. So this is the locus, and since the coefficients of x and y are the same, I think we realize that here coefficient of x is 1, coefficient of y is 1, and the other rest of the terms are linear. So all these terms are linear. It implies that the locus is a circle. Then by comparison with the general coordinate of the circle, G will be this, F will be this, and C will be this. I believe by now you know where they come from. Therefore center will be this and radius will be given by that. Then question 2 came from UNEB 2018 paper 1 question 5 and says a point P moves such that its distance from 2 points A and B are in the ratio this. Show that the locus of P is a circle. So still we shall let the variable point P be xy. Therefore, Hamann caught the condition which was given. Then remember, this one is the same as AP over PB equal to 3 over 2. Therefore, when I cross multiply, I come up with 2AP equal to 3PB. Therefore, AP is the distance between A and P, and PB is the distance between P and B. Therefore, those are the formulas. Don't forget the 3. Then square both sides. That's why this 2 becomes 4 and this 3 becomes 9. Then open brackets on both sides and collect like terms. So this will be the locus. Now here we have to conclude that since this x squared and y squared have the same coefficients, remember this is coefficient 5 and this is also 5, and the rest of the terms are linear, all these remaining terms are linear, it implies that the locus is a circle. So now we shall go to question 3, which came from UNEB 1999 paper 1 question 9, and says the locus of P is such that the distance of P is half the distance PR, where O is the origin and R is the point. This Roman 1, show that the locus of P describes a circle in the xy plane. So I think let's begin with Roman 1. So let P be xy. We are given that OP is half PR, so we have to code that. So that will be our condition. Then distance between O and P is that, and distance between P and R is that. This half is maintained. Then square both sides, that's why this half becomes a quarter. So expand, I'll come up with that, and simplify and rearrange to come up with that. Then reduce to come up with that as the locus. Therefore, we have to conclude that since the coefficients of x and y are the same and the rest of the terms are linear, then the locus is a circle. Then now we shall go to Roman 2. Roman 2 says determine the radius and center of the circle. So by comparison with this, G will be that, F will be that, and C will be that. Therefore the center will be this, and the radius will also be that. Then Roman 3 said, where does P cut the line x equal to 3? So when x is equal to 3, it implies that, remember, this is the locus of P, therefore where there is x put there 3 to come up with a quadratic in y, solve it, then you come up with two values of y equal to 2 and y equal to -6. Therefore P cuts the line this at points 3, 2 and 3, -6. Then now we shall go to question 4, which says that the points these and this are such that PB is equal to 2PA. Show that the locus of P is a circle and hence find its center and radius. So still we have to know the distance between 2 points. So between P and B is that, between P and A is that, and this 2 is maintained. Square both sides, will come up with that. Open brackets to come up with that, rearrange to come up with that, reduce to come up with that. So this will be the locus, but they also told us to get the radius and center. So the G is that, F is that, and C is that. Therefore center will be that and radius will be that. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on parabola, which is under conic section. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on conic sections or parabola has been uploaded. And also If you know any student who's not yet in those platforms, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.